So today we'll look at Book 4B, Chapter 12, more about basic properties of circles. So let's look at cyclic quadrilaterals first. So this term, you have came across it in some of the questions from the previous chapter. So today we'll look into this. So a quadrilateral with all the vertex lying on a circle is called a cyclic quadrilaterals. So let's look at the angles in this cyclic quadrilaterals first. So if you got a textbook, you can turn to your page 12.2 and have a look at this class activity 12.1. So this class activities, you will have to draw a circle on a piece of paper and select any 4 points on a circle, and then you join these points to form a cyclic quadrilateral. Then you cut it out. So once you cut it out, tear off the 4 marked angles, try to fit 2 of the angles against a ruler. So you realize the opposite angles add up together will give you 180. So this is in fact our first theorem. So the opposite angles of a cyclic quadrilaterals are supplementary. And if we look at the diagram here, angle P and angle R add up together is 180, and angle Q and angle S, you can say that is add up to 180, because we have the reasons of opposite angles cyclic quadrilateral. But if you don't want to use the class activity, the hands-on activity, to prove this theorem, then you can actually look at this here, the next slide. So in this diagram, you got a cyclic quadrilaterals because all 4 vertex of the quadrilateral is inside a circle. And then in here, if we join a line OQ and OS together, we can see that X is actually equals to 2 of the angle P because of angle at center twice at angles at circumference. And then the same thing for Y will equals to 2R because angle at centers twice at the angles at the circumference. And then X and Y, you can see they add up together to give you 360 because they are at the point. So using angles at the point, they add up to 360, and when you simplify it, you can have a conclusion that angle P and angle R add up to 180. And using the same way, you can prove that angle Q and angle S is equal to 180 as well. So we now just look at how this theorem can be proved using 2 different ways. And now let's look at how we can use it actually to solve the question. So in this figure here, angle ADB is 40 and then angle ABD is 20 degrees. So find X and Y. So let's look at what information they gave you. So they gave you these 2 angles here. And you can see that this is a triangle. Whenever you got 2 angles, then you can find the third one using your angle sum of triangle. So therefore, you can find an X. So X plus 40 degree plus 20 degree will equals to 180 because angle sum of triangle. Okay, so therefore, X is equals to 120 degree. So once we got that, let's look at what other information they have. You can see that those 2 angles are the only one they gave you, but if you look carefully, this is a quadrilateral and all vertex is inside a circle. So therefore, this is a cyclic quadrilateral. And what we have learned just now about cyclic quadrilateral, the opposite angle add up together give you 180. So X and Y is the opposite angle. So therefore, using your opposite angles cyclic quadrilateral, you can find the angle for Y. So X is 120 plus Y equals 180. So therefore, Y is 60 degree. Okay. The second example, in this figure, AD is the diameter of the circle. And if arc CD is equals to arc BC and angle ABC is equals to 130, they want you to find the angle BED. So let's look at where's angle BED. So this is your angle BED. So always look at what they want you to find and start from there. So we're always doing a backward thinking here. So we know that BED is here, and you can see that There's no information at the lower part of your circle. So therefore, we have to think of a way to find it. So if we look carefully, this is a quadrilateral, and all the vertex is inside the circle. And therefore, if you have these opposite angles added up, you will get 180 because of the opposite angles cyclic quadrilateral. So therefore, meaning that if I can find angle BCD, then I can probably find my angle BED here. Okay, so how do we find our angle BCD here? So we look at the information we have. So AD is a diameter. So what does it tell you? They tell you that they give you that information for a reason, isn't it? So think of what you have learned in the previous chapter. You got that angle in a semicircle, isn't it? If you know that that's the diameter, they can cut the circle into a semicircle, and then you will have that information. One of the information. What is that information? Your angle will be 90 degrees. Okay, the angle of that triangle. But the thing is, there's no triangle at that upper part of your circle. So therefore, we create one ourselves. So let's try to draw the line BD. We join the point B and D together. Then we got a line and we got two triangles, you can see. So let me highlight this triangle first. So you got one triangle here, and then you have another triangle here, isn't it? Okay, so using the information that AD is a diameter, then we know that this angle here, ABD, is going to be 90 degrees because of angle in semicircle. Okay, and because we know that this is 90, then obviously we know what is this one. So angle CBD is equal to angle ABC minus angle ABD. So 130 degree minus 90 degree, and you get 40 degree. Okay, so once we know that this one is 40, what should we do? So that red triangle, you now have one information, one of the angle, so you want one more in order to find the third one. And then we look at the second information they provide. These two arc lengths are equal, so arc CD is equal to arc BC. So what does it tell you? So remember, equal arcs equals angles. So angle CDB is equal to angle CBD, so 40 degree, and this is actually an isosceles triangle. But we don't have to use the reason for isosceles triangle here, because once you got those two angles, you can find a third one using angle sum of triangle. So angle BCD, adding angle CDB and your CBD equals 180. So angle BCD adding 40 and another 40 will equals 180. So angle BCD is 100. So once you find this one, we can use our opposite angle cyclic quadrilaterals to help you to do the final part. So angle BDD, the one you want to find, adding the angle BCD equals 180. So opposite angles cyclic quadrilateral. And therefore, BED adding 100 is 180. And therefore, your BED is 80. Okay. So you can see that in these examples, we have used our opposite angle cyclic quadrilaterals, but we have also used what you have learned in the previous chapter as well. Okay. So then we will have to look at your exterior angles of a cyclic quadrilaterals. But before that, we will have a look at more questions on this first. So let's go to the worksheets. Okay, so let's look at Consolidation Exercise 12A worksheets together. So instead of looking at question 1 and 2, let's look at question 3. Because you can see question 1 and 2, we just need to use opposite angles cyclic quadrilaterals directly, then we can find our unknowns. But in question 3, you have to use a little bit of your the reasons you have learned in in chapter 11. So let's use it as a revision as well. So let's look at here. You have to find the unknown, so therefore we are looking for D and F. And you will say, isn't it opposite angles of cyclic quadrilaterals? Yes, they are. So D and F add together, supposedly you will get 180 degrees. But the thing is, you don't know what is D, you don't know what's F, so therefore you have to find out either one of them. Okay, so at least one of them you have to find it. And let's look at what information you have first. The information you have is this angles at the center. So can you remember what we talked about before? Angle at the center. So the things you should remember is the angle at the center is twice the one at the circumference. So here is the shape we like to have a look at. Okay, so meaning that 180 is actually twice the angles on the circumference, which is your angle D. So let's write it out. So angle AOC is equals to 2 of the angle ADC. So with the reason angle at center twice angle at circumference. Okay, so therefore 140 degree is equals to 2D, and D is equals to 70 degree. And once we got that, we just said that D and F add up together give you 180, isn't it? So this is what we have learned today. So adding up give you 180 because of your opposite angles cyclic quadrilateral. Okay, so F adding this 70 give you 180. So therefore F is 110 degree. Okay, so any problem with this one? Okay, if you got no problem, then we'll look at question 7 together. So in this question here, let's look at the information. So you still need to find the unknown, A and B. And in here, let's look at what we have got. We got this 70 degree here, and we got this 2 as the isosceles triangle. So therefore, we know that this angle will also be your angle B because of base angles isosceles triangle. And this one here, adding up together will give you 180 because of opposite angle cyclic quadrilateral. So let's start with this here. Because we can't find angle B if we don't have angle A. So let's start with angle A. So angle ADC adding your angle ABC equals 180. Opposite angles cyclic quadrilateral. So A plus 70 degree equals 180. So therefore, A is 110 degree. Then we look at this triangle ACD. So we can always have a habit of writing an angle ACD, so you know which one you're talking about. So because CD is equal to AD, given, okay, so make sure it comes into a pair. So ACD equals angle CAD equals angle B. So this is your base angles isosceles triangle. So make sure you don't write this isosceles triangle reason wrong. Then because we know that all the angles add up together in a triangle is equals to 180, so we can find the unknown B. Okay, so then add up together give you 180. 2B equals 70, so B is equals to 35 degree. Okay, so this one use some of the reason you have learned in Form 2, your angle sum of triangle and base angles isosceles triangle. Then we look at how about question 8? So the one below. So in here we got some information. So let's look at what you need to find first. So you have angle B is the one you need to find, angle A is the other one you need to find, And we have this other information. So this is 120 and this is 90. So how are we gonna use it? Okay, so let's have a look together. So if we look carefully here, we can make it as two cyclic quadrilaterals. So the first one, A, B, C, D. So we got one here. So we'll look at it. So angle A, if we talk about angle A, the opposite, then these two are the ones that add up together give you 180, isn't it? So angle BCD adding angle BAE equals to 180 degree. Opposite angles cyclic quadrilateral. Okay, so actually let me write this here as well, so you know which one I'm talking about, because later on you'll see that in this question we can use two different cyclic quadrilaterals here. So the first one we're using is a ABCE. So A plus 120 gives you 180, so therefore A is 60 degree. Okay, so we found one of our unknown. And then we look carefully, we need to find the other unknown B. B here. But if we use this quadrilateral, it can't help because we need a little bit more information for that. We only have a little bit of it. So this one here, we do not know what is angle AEB, so we can't use our opposite angles cyclic quadrilaterals, and we don't know this one here, so it's not going to be useful at all. Right? So therefore, let's look carefully. Instead of looking at this here, you realize this is actually a triangle, isn't it? We got a triangle here. So we found this one already. If we can find this angle, EBC, then we can probably find B because angle sum of triangle. But the thing is, how do we find EBC? So angle EBC, how are we going to find it? So look carefully. This is a quadrilateral and it is inside a circle, so this is a cyclic quadrilateral. So this angle here is going to add up with this one to give you 180. So in cyclic quadrilateral, so this is the one we're looking at right now, BCDE, then we know that angle CBE adding this angle CDE will equals 180 using your opposite angles cyclic quadrilateral. So CBE adding 90 give you 180, so of course this will equals to 90. Once we have this, then we can use our angle sum of triangle. In triangle BCE. Okay, so we always write this out so that we know which one we're talking about, especially when you have complex shapes, many lines, many triangles, or many quadrilaterals inside one shape. Then you know which one you're talking about. You won't confuse yourself as well. So using angle sum of triangle, we can find that B plus 60 plus 90 equals 180. So therefore, B is 30 degree. So we're using opposite angles cyclic quadrilateral twice and using two different cyclic quadrilateral. So therefore, it's very important for you to spot the quadrilaterals inside the circles. Let's look at question 16. So in here, they want you to find angle BED. So this is the angle here. And be careful with that. Quite a lot of you might think, okay, so angle BED, adding that 136, isn't it 180 because of opposite angles cyclic quadrilateral, right? But look at this. Is this really a cyclic quadrilateral? No, it is not, because for cyclic quadrilaterals, all the vertex has to be lying on a circle. But this point E here is not lying on the circle, so this is not a cyclic quadrilateral. so we can't find it. But if we look carefully, this angle here, okay, because we got one more information other than that 136, and then we actually have one more information. We got this 670 degree here. So 70 degree is inside the triangle ABE, and your angle BED is actually an exterior angle of the triangle. So meaning that if I can find this BAD, I can probably find my angle BED. But can I find my angle BAE first? So yes, because this is a cyclic quadrilateral when all the vertices are lying on a circle, and this is actually the opposite angle. So therefore, BAE adding your BCD is equal to 180, with the reason of opposite angles cyclic quadrilateral. So therefore, BAE is actually 44 degree. Okay, so once you got that, then you can use the exterior angle of triangle to find your answer. So angle BED angle BED is equals to BAE adding ABE, exterior angle of triangle, and then 44 adding 70 is equals to 114. Okay, so therefore make sure when you want to use that cyclic quadrilateral, make sure that is actually a cyclic quadrilateral first. Part B, finding your angle ADO. So this is your ADO, isn't it? Okay, so by looking at ADO, we first look at, okay, we got a triangle here, but we don't have any information there. But remember this one, you found it just now. So we kind of have one information outside that triangle, which is your exterior angle. Okay, but for a triangle, in order to find the third angle, you have to have two information first. But first of all, we only have one. I mean, even though you tell me that 180 minus that BED 114, you will get this angle here. But the thing is, that triangle, you still don't have the second information because those two count as one. So in order to have the second information, and by saying second information, we're talking about angle EOD. Okay, EOD. So what do we know about this angle EOD here? This is the angle at the center. Okay, angle at the center. So when we talk about this angle at the center, then probably you know what we're gonna use. We're gonna use angle at the center twice the angle at the circumference. But which is the angle that is at the circumference here? So which one should we be looking at? So look at this shape here. Okay, so this is gonna be the angle at the circumference. So let's write it down first. So for part B, actually I can write here. So for part B, I'm gonna write here. Angle BOD is equals to 2 of the angle BAD. So angle at center twice angle at circumference. So it equals 2 times 44, which you found in part A. So it's 88. So once you got that, then we can say in the triangle ODE, we can use the exterior angle of triangle. So find ADO adding BOD equals BED. So therefore, ADO is gonna be 26. So let's look at question 18 here. So question 18, it tells you that the arc AB is equal to arc AD and also arc CD. And then they also give you that CAD is 50 and find angle BAC. So let's look at what is BAC first. So this one is BAC. And you know that they tell you this arc are equals for a reason, isn't it? So if this arc are equals, meaning probably there are some angles are equal as well. So these arc are equals. Okay. So let's see. If this arc are equals, which angles are actually equals as well? So let's have a look. So angle BCA is gonna equal to your ACD and also equals to your CAD as well, so which is 50. Okay, so write it out first. So you don't know is it gonna be useful, but they give it there probably is useful. So write it out first so it will be more clear. So this is given. So your BCA is equals to your ACD, also equals to your CAD, which is 50. And this is your equal arc, equal angles. Okay, so once you got that, then meaning that we have these two angles here. And look at this. This is actually a cyclic quadrilateral. So if we have this angle here, then meaning that it will equals to added the opposite angles will equals to 180. So therefore, BAD plus angle BCD should equals to 180. Write down the reason. And then once you write down the reason and try to list out the angles that create those angle BAD and BCD, you'll have angle BAC plus angle CAD plus angle BCA plus angle ACD equals to 180. And then the only unknown will be your BAC because all three of them is your 50 degree. Okay, so then therefore your angle BAC is equals to 30 degree. So in this case here, we have used the equal arcs, equals angles to help you a little bit before you can use your opposite angles cyclic quadrilaterals. Okay, so some of you might think I really can't see where is the equal arcs, equal angles. So let me draw it out again. Okay, so have a look at this part again if you're confused about that equal arcs, equal length. So this is the equal arc, isn't it? Okay, and this is the part you should be looking at. And then this is the equal arc, right? And then the last arc is here. Okay, so therefore you can see that the first arc, this blue one here, the angle is this one. And then the orange one, you have the arc there, and then the angle is this one here. And then the last one, you have the yellow arc, and then this is the yellow angle here. So therefore, those three are equals. Your angle BCA, your angle ACD, and also your angle CAD. Okay, so they're all equals to 50. So make sure if you need it, then you just highlight the things you want in the... So let's look at this question 26 together. So this is the information they gave you. So this time they give you information about the arc length as well, but instead of telling you the arc length equals, they give you the ratio. So it means that you're not using your equal arcs equals angles anymore. You should be using the arcs proportion to angles at circumference at some point, probably, because this is the last theorem you have learned in chapter 11, and that information shows you that they want you to use it that way. Okay, but before we jump to that point, let's look at what other information we have. So we got this 100 degree, and we know that the diagram is also hints as well. We got the shape inside a circle. All the vertex is lying on the circle, so this is a cyclic quadrilateral. Okay, so therefore, if we have this 100°, we know what is this angles here, ADC. So let's do this first. So angle ABC plus ADC is equals to 180. And then the opposite angles, cyclic quadrilateral. Right? So got 100°, adding that angle ADC equals 180. So meaning that your angle ADC is 80°. Okay, so we got this part, and now is the next part. They give you the information about the ratio, so we should be using it, isn't it? So let's write down first. So because your arc AB is proportion to arc BC, and then arc DC equals 3 to 1 to 2. So this is given. And you know that you want to use your angle BAD. So let's look at where's your angle BAD first, probably. So BAD is here, right? And this angle, you might think, how is it going to link to the arc? So look at this angle here. The arc should be this one. Okay, it should be BCD. But the thing is, the one you got is only AB, BC, and CD. So therefore, you have to try to find a way to combine it. Okay, so let's have a look. If I want to combine it, somehow I want to have this BCD, isn't it? Right? And then I should have another one compared with it. So let's look at which one comparing it together will give you some information you want. So probably we want to use the other angles you have so far. So let's have a look at this. ADC is the one you have. And if we're looking at this ADC, which arcs should we be looking at? We should be looking at your arc ABC, isn't it? So arc ABC and BCD. So let's find the ratio of this first. So arc ABC is actually 3 plus 1, isn't it? Because AB and BC is 3 and 1. And then BCD, how about? BCD is BC and CD. So it will be 1 plus 2. And therefore, the ratio will be 4 to 3. And because we know the ratio of the arc, ABC to BCD, we know that the ratio is going to equal to the angles at the circumference, which is ADC and BAD. So write down this arcs proportion to angles at circumference. Okay, so therefore 4 to 3 is equals to 80 degree to angle BAD, and BAD is your only unknown, so therefore angle BAD is equals to 60 degree. Okay, you got it? So then the next part, it says I want to find the ratio of arc AB to arc AD. So how are we going to find that? Before we move on to part B, just make a change here. I think I wrote BAC originally, so change it to BAD. I just accidentally write wrong, so it should be BAD. Okay, so just go back to part B. So arc AB to arc AD is the one you want to find. Okay, so let's write out what they provide first. The things they provide that is linked to the arc is this one here, the ratio of your arc AB to arc BC to arc CD. This is given. But the thing is, we don't have AD. Okay, and you know that the arc is proportional to the angles at the circumference. So we can actually use this point properly to help you find what's AD. So let's look at this arc here, AD. Right, this one is the arc AD, and therefore the corresponding angles at the circumference should be this one. So meaning that I have to draw a line here, and then you can find this angle here. So meaning that if we somehow find angle ABD, then we can probably find the arc AD. But the thing is, for that angle, how can we find it? We don't have other information apart from that that ratios of the arc length. But don't forget, we actually got these angles from the previous question, part A. So how about we write it down first? So this is 60 degree. Okay, and looking at this, we know that this is corresponding to the arc here. So this angle is corresponding to this. And now you got one angle inside that triangle ABD. So probably, if you can find the angle of ADB, maybe it can help as well. So then I try to think about, what is this angle ADB? I do not know it, but let's look at this. The arc that is corresponding to this part is your arc AB. So do we know what is arc AB? We actually know what is arc AB. So perhaps we can find if there's any relationship between arc AB and BCD. So 3 to 1 plus 2, because BC to CD is actually BCD. So it's 3 to 3, and for ratio, you can simplify it by dividing the same, if both of them is 3, then you can divide the 3 together and you get 1 to 1. What does it mean by 1 to 1? If the ratio is the same, meaning that arc AB is actually the same length as arc BCD. So equal arcs. So now you got one information about equal arcs. Equal arcs give you equal angles. Equal arcs equals angles. So once you got that angle is 60, then what do? You got this as 60 as well. So you got 60, 60, and then the third angle, just find it by using your angle sum of triangle. So write out. They add up together 180 because your angle sum of, angle sum of triangle, 60 plus 60 plus angle ABD equals 180. So therefore, angle ABD is equals to 60. Once you got this angle ABD, the red one, then we can use the ratio. You can use it to find the ratio. Arc AB to arc AD is actually equals to angle ADB to angle ABD because of your arcs proportion to angles at circumference. So both of them are 60 degree. So therefore, your arc AB to AD will equals to 1 to 1.